Hey, and welcome to today's presentation. We're looking at the gait analysis of the stance phase during running. We're going to go over some biomechanic principles and look at what we can improve upon during this activity.
What are we going to observe? There are two phases in gait analysis, stance and swing, and we're going to focus on the stance phase. While running at a peak velocity, we analyze one leg during the movement as it passes through all of these phases. The stance phase of gait begins when the first foot touches the ground and ends when the same foot leaves the ground. The stance phase makes up approximately 60% of this gait cycle. During contact with the ground, some key components involve the foot being flat when contacting the floor, a slight anterior tilt of the pelvis, knees vertically on top or slightly in front of the ankle when contacting the ground, and a consistent ground displacement height of the hips.
What is the goal of gait analysis? Gait analysis is extremely important for increasing performance in sprinting, running, and gaining valuable milliseconds over the competition. But it's also really important for injury prevention. Gait analysis can determine if joints are being overloaded or underutilized, and it can also discover new ways to reduce pain runners may have during this exercise.
Here we can see a deterministic model of the stance phase of gait analysis. In order to achieve a good gait analysis, we need to go through three phases of our stance: the initial contact, mid-stance, and takeoff. Through our stance phase, we need to go through our initial contact, which revolves around striking the ground with the foot. A bad striking phase would be to strike the foot on the heel, whereas a good strike phase would be to make contact with the ground with the middle of the foot. For our mid stance, it revolves around joint stacking and leverage, which will lead to the momentum that we're going to achieve to go into our next part of the phase, which is takeoff. Takeoff is a large component that requires power and elastic recoil of the hip, propelling the body forward. This will give us flight time. All three of these will equivalent to our stride length, which is a key component to increase or maintain speed during a long run. Principles needed to achieve effective gait through the stance phase. Some of the qualitative principles that we need to go through are knees slightly in front of the ankle in the mid-stance phase, a flat foot during initial contact, and hip distance during takeoff between the front leg and the back leg.
With our qualitative principles being levers, Newton's law of force and acceleration, and stride length and flight time. Here is just a look at our key qualitative principles during this stance. In the first picture, we can see an anterior tilt of the hips that stays consistent about 80 degrees, the knee, which is slightly in front of the ankle during our mid stance, and a flat or mid-foot initial contact during our initial contact of this run, which is the ankle plantar flex at roughly 6 degrees. So here are some qualitative principles that we're going to look at, which is the levers that we can see. So the knee acts as a third-class lever, where the knee is the fulcrum, forces from the hamstring and quadriceps. This is seen during the mid-stance and the takeoff phase, where the load of the athlete's body is seen here as force, and it is superior to the fulcrum. Taking a look at the ankle is a second-class lever, and it's seen during our takeoff phase, where the calf muscles plantar flex to propel us off the ground. An efficient use of this lever is seen when the ankle flexes as the body mass moves anteriorly from the ankle joint, allowing weight to move faster as it's displaced away from our body. Looking at mass time acceleration, the greater the mass, the greater the acceleration. Mass and acceleration need to be increased upon to manipulate and increase speed. We can achieve this by a slight leaning forwards, landing on the midfoot and stacking the ankle, knee, hip joints. During our second phase, a vertical line to produce greater ground reaction force, which will increase the body's mass into the ground while running. This produces forces back onto the foot, helping and propelling us forwards. Having a look at our recording equipment and features. We're doing this inside, so we need to have a treadmill with the ability to run up to 20 kilometers. We're recording this, so we need to have overhanging lights on top, and we need to have a standing light in front of us. We also need to have a camera with the availability to do 124 frames a second in slow motion, while also being positioned at 107 centimeters of height and 3 meters away. We need to put reflective markers on the ankles, knees, and hips to look at all the joints. We also need the participant to run for 15 seconds at a velocity of 19.6 kilometers. Now that we have an understanding of the biomechanic principles, we're going to take a small qualitative review of this run. Looking at our first image, we can see the athlete starts with a bad heel strike, landing with a hyperextended knee and an ankle into the floor. This can lead to several injuries with meniscus and fat pad issues on the calcaneus. We have a good second stage with the knee in front of the big toe, forcing mass anteriorly, assisting momentum, utilizing the fulcrum of the knee. The third stage, the hips have stayed at the similar height for the duration, using the fulcrum of the ankle to produce forces from the calves as they plantarflex into the ground. Stage 4, our takeoff phase. We see the athlete has further flexed his hips, anteriorly tilting from the pelvis while leaning forwards to keep the athlete's momentum going in the direction of the run. Otherwise, extension, which we see from the knee, hip, and calf, would send us vertically, reducing our momentum. Now we're going to detect some of our faults in this performance. So, to first start, we're going to look at our heel strike fault. The heel strike is the development of overstriding, making contact with the ground while the heel is either too upright, or with the leg contacting the ground too far in front of the knee. It tends to inhibit performance, decreasing the ground reaction force, decreasing momentum, and is often linked to injuries including calcaneal fat pad thinning and patellofemoral pain. So as we can look at this, we can see the angle of my foot is at 107 degrees instead of a flat 90 degrees. Also, we can have a look at our knee, and it is almost fully extended instead of sitting at a nice neutral position where momentum and contraction can roll forwards, propelling my body in a horizontal direction. Okay, we can also see here that at the extension of the knee in the top picture is very likely to cause that knee pain and that hyperextension. Also, that ground reaction force is going to go directly into our foot, knee, and hip instead of into our levers, pushing us forwards as we continue our run. Compared to the image below, we can see Kipchoge's initial step, where he is contacting the ground with a flat foot, a bent knee, and his hips at a very slight tilt, body's upright, and momentum's traveling forwards. But on my image, we see that I'm very bent forward, stiff together, and compact. And another thing that we can notice that is almost similar is that there is a bit of hip extension, but not enough. Kipchoge's back right hip is extended very far, whereas my hips are close together. I'm reducing my potential for elastic kinetic energy to travel me forwards, starting that next step faster, also reducing my stride length, decreasing my flight time, preventing me from traveling faster than I could be. So to correct this, I need to land with a flatter foot or a midfoot instead of impacting on the calcaneus bone. There are so many drills and technical training mechanisms to fix this common mistake. The first adjustment would be applying a forward trunk lean to move mass forwards and attempt to place the hips over the knees and toes. There's some performance drills, like a short 5-minute warm-up, where these examples are high knees, side shuffles, running backwards and skipping, and then trying to purposely land on the center of the ball of my feet instead of landing on the ankle. It will feel awkward, but it is one of the best ways to enhance that performance by forcing yourself to land on your ankles. Looking at our qualitative analysis. So we have taken some measurements. The athlete's at 86 kilos. The machine is set to 19.6 kilometers. And we can measure the force produced by timesing these together. I believe we get 46 kilograms of force from this. So this is going to potentially push us forward. A professional athlete usually gets close to, in this run, very similar, but their bodily is initiated and biomechanically settled in a much better position. So they're going to travel forwards much easier, smoother, and faster. A quick summary. For this athlete analysis, we learned that his stride lengths, initial contact, takeoff phase were being underutilized by our principles, decreasing his momentum, his ground reaction force, not utilizing levers, and a poor athletic technique, with too many forward leans, decreasing the range of motion in his right hip when he was doing his swing, and potentially harmful heel strikes and hyperextension of the knee when contacting the ground. Suggestion for performance is to review the initial contact, practice landing flat-footed with a slight bend at the knee, contacting in the mid-foot, while also standing upright and taking larger steps to increase the stride length, which will give valuable milliseconds to their performance. Thank you for watching, and that's just my citations below. Cheers.